Hello everyone. In this video I am going to demonstrate a constant current source using a MOSFET. In this circuit the MOSFET will be operating on a linear region. So as you can see here, this is my setup. I have wired my setup on a breadboard. I am using MOSFET IRF840. As you can see, this is my MOSFET and this setup is capable of giving a constant current between 0 to 22.5 milliamps. As you can see, this is my setup. This setup can be used as a 0 to 20 milliampere loop calibrator. So as you can see here, this is my setup. So let us look into the circuit diagram first, then we will be observing the performance of this circuit. So as you can see, this is the circuit diagram of my constant current source. So as you can see here, this is my constant current source. The voltage between the gate and the source is controlled here. With this setup, you can see this is a zero adjustment potentiometer here. So we can adjust this potentiometer in order to convert this circuit into a 4 to 20 milliampere current source. So as you can see here, this is the main potentiometer. This potentiometer has to be used in order to control this drain current. So this is a zero adjustment potentiometer. Wherever we want this drain current at the initial stage, that has to be adjusted using this zero adjustment potentiometer. So as you can see, suppose we want to adjust this circuit between 0 and 20 milliamps, then we have to adjust this potentiometer to the 0 milliamps. And after that, once we adjust this potentiometer, the maximum value we will be getting in this circuit is 20 milliamps. So this is the setup. You can see this is 330 ohms 1 watt resistance at the drain, and at the source it is 330 ohms plus 100 ohms 1 watt resistances each. So this is the graph for the gate to source voltage versus the drain current. So this is a linear graph. At 0 milliampere, the gate to source voltage has to be 2.59 volts, and the gate voltage will be 12.94 volts when the drain current will be 22.5 milliamps. So this gate to source voltage is adjusted using this potentiometer, and this is the zero adjustment potentiometer. So this is how my constant current source using MOSFET works. I am using MOSFET IRF840 in this source. So this source or this circuit can be used as a 0 to 20 milliamps or 4 to 20 milliamps loop calibrator. For 4 to 20 milliamps loop calibrator, we have to adjust this 0 to the 4 milliamps. This potentiometer we have to adjust to 4 milliamps. For 0 to 20 milliamps, we have to adjust this potentiometer to 0 milliamps. We have to adjust this potentiometer such a way that the drain current is 0 milliamps. For 4 to 20 milliamps, we have to adjust this potentiometer so that the drain current is 4 milliamps. So like this is a constant current source. This is the test setup for a constant current source that I have implemented. So let us look into the multimeters. So here you can see this is the setup. Here you can see the voltage. So this is the gate to source voltage, and this is the drain current. So you can see the drain current is now 22 milliamps. So I can reduce the drain current and I can make it 20 milliamps. You can see here I am reducing the drain current now. You can see the drain current is now 20 milliamps. You can see the gate to source voltage has changed. You can see the gate to source voltage will change as soon as the drain current changes. So let us make this drain current to now 16 milliamps. You can see the gate to source voltage is also changing. So let's make the drain current to 16 milliamps. So the drain current is now 16 milliamps. You can see here the gate to source voltage is 10.12 volts. So let us decrease the drain current to 12 milliamps. You can see the drain current is now 12 milliamps. I have reduced it further. So the drain current is now 12 milliamps. You can see the gate to source voltage is 8.3 volts. Let's reduce it further to 8 milliamps, the drain current. I am reducing the drain current to 8 milliamps. can see the drain current is now 8 milliamps. The gate to source voltage is 6.65 volts. Let's reduce the drain current further to 4 milliamps. I'm sorry, I turned it in the reverse direction. So you can see here, this is the 4 milliamps drain current, and you can see here the voltage is 4.8 volts DC between the gate to source. So here you can see this is the test setup, and here you can see this is my adjustment potentiometer. This is a 10K potentiometer. You can see here this is the 10K potentiometer, and here is the zero adjustment knob. So this is how my constant current source behaves. This is the operation of a MOSFET in its linear region. This circuit can be used as a loop calibrator as well for 0 to 20 milliamps scale in the industries. Thanks a lot. Thanks for watching.